Welcome back to the course on how to build your own AI agent from scratch. Here's what we've accomplished so far. The first thing we talked about was ChatGPT, and then we talked about the problems with ChatGPT, it being unable to execute actions or know things in real time. We introduced tools, which are ways for ChatGPT to actually do things on our behalf. We also introduced the orchestration loop and ways so the agent can execute things automatically or with user approval. This includes a toggle switching to automation modes or even something like a whitelist of approved tools. Finally, we talked about how do you start or trigger an AI agent, whether that's a manual start, via API call, via webhook, or a scheduled job. And we talked about sub-agents, how sub-agents are specialized AI agents that are triggered from a parent agent. They tend to have a different set of tools, a different system prompt with different instructions that make it specialized for a specific task. Now we're going to talk about one of the most important decisions you have to make for your AI agent. Right now, it's an art, not a science. This thing is called memory. Now, let's turn our attention to the screen. We have this AI agent. I'm on the OpenAI playground, and I just have this, "You are a helpful assistant" message. I'm going to type into the chat, "What is my name?" I already gave it my name, so it should know my name. It says, "Your name is Austin." This is good. Now, let's refresh the page and start from scratch. Let's go back to "You are a helpful assistant," and I'm going to say, "What is my name?" If I say this, the AI doesn't know. It doesn't have any memory. So let's say after this agent runs, let's go to a completed agent as a prime example. After the agent runs, we're going to take all of this information and literally just copy paste it into a file. And so the next time the agent runs, it's going to have a tool. The tool is going to first query memories, first read this file. It's going to know what it did last time, and then it's going to repeat so that it already knows what it did before. This is a simple way of implementing memory, and it works for some basic use cases, but there are a number of issues. For one, all of this stuff is not really relevant. A long conversation being prepended to the beginning of a conversation, that's not super helpful, and it's expensive. Language models charge you per token. So if you have all this information having stuff it doesn't need, then you're getting charged for no reason and worse performance. You might just need the list of portfolios you've created before. You might not need all the other information. So the next part of having memory isn't just a raw dump, but just having an LLM take the entire conversation, summarizing all the parts that you need, and then just putting that in a file. Maybe you just need this. This is one file, and every time an agent runs, it's just gonna append information to this one file. This is actually a fairly decent way of implementing memory naively. You can have different smarter strategies. Maybe you'll have this file, which is just the list of portfolios it's created, and then maybe another file that's a list of backtest results, and the AI agent has tools to know which files it should query into the context window. That's another strategy. That's something AI tools like Cursor and Claude Code do all the time. It reads the files from the system when it needs them. That's another great way of implementing memory. You also don't need to just store it in files. You can store all of this in a database. You might want to index the text fields, maybe have some categories to make it easy to query, but you want to store the information somewhere. Well, it can be queried by the AI agent. This is the easiest, lowest lift way of implementing memory, and with modern day LLMs, it works pretty good. But it doesn't work all the time. Sometimes you might have entire documents, hundreds of pages, and you need your language model to find the information within those documents. And you can't just dump 100 pages into the context one. That's gonna be way too expensive. So what you can do instead is store it in a vector database. I'll explain that in the next video. This is critical. If you're trying to do an AI native systems design interview, this is very important. Stick around and see you in the next video.